Hello everybody. Today let's solve Leetcode 20 valid parentheses. We're given a string S containing just the characters, and then we have the opening and closing brackets of three types of brackets. Determine if the input string is valid, and we're given three conditions that must be met for that string to be valid. So again, we're given a string S, and the string can only contain these characters, the opening and closing brackets of three different types of brackets. And our job is to write a function that tests whether the string is valid or not based on three conditions that are given to us. The first condition states that all open brackets must be closed by the same type of brackets. What that means is if we have an open bracket of type 1, it must be closed by a bracket of type 1 also. And in this example, yes, it is closed by a bracket of type 1. The other open bracket in this string is type 2, and it is also closed by a bracket of type 2. So this string satisfies condition number 1. The second condition states that all open brackets must be closed in the correct order. Now, what does it actually mean for open brackets to be closed in the correct order? How can we define correct order? We can define it like this. To tell whether all open brackets in string S are closed in the correct order, when traversing the string and encountering a close bracket, that close bracket must close the most recent open bracket that we encountered, which in this case is this open bracket of type 1. They are both of the same type, and there are no other open brackets in between them. Therefore, we can conclude that this open bracket has been closed in the correct order. Then the other close bracket in this example is close bracket of type 2. And at the time of reaching this close bracket, the most recent open bracket that we have encountered is this open bracket. The close bracket that we have encountered is of type 2. And the most recent open bracket that we have encountered is also of type 2. And therefore, we can conclude that this open bracket is also closed in the correct order. Since both open brackets in this example are closed in the correct order, we can conclude that condition number 2 is satisfied for this example. How about this example? Recalling the definition of correct order, it's when as we traverse the string S and encounter a close bracket, the close bracket must close the most recently encountered open bracket. In this case, the most recently encountered open bracket is this open bracket of type 1. Unfortunately, it is not the same type as the close bracket that we encountered. Therefore, we can conclude that this open bracket has not been closed in the correct order. For this open bracket to be closed in the correct order would be to close it here. And for this open bracket to be closed in the correct order would be to close it here. Now the two open brackets in this string are closed in the correct order, and this string therefore does satisfy condition number 2. However, what about condition 3? Condition 3 states that every close bracket has a corresponding open bracket of the same type. Now, in this example, we have 4 closing brackets. This close bracket has a corresponding open bracket of the same type. This close bracket also has an open bracket of the same type. However, these two close brackets do not have an open bracket of the same type. Therefore, this string does not satisfy condition number 3. Let's look at another example. This example has 2 close brackets. The outer close bracket does have a corresponding open bracket of the same type. However, the inner close bracket does not have an open bracket of the same type, because this open bracket is of type 3 and this close bracket is of type 2. Therefore, this example does not satisfy condition number 3. Okay, now let's go through a few examples and check whether they meet the conditions to be valid or not. So starting with condition number 1, we have 3 open brackets. This open bracket of type 1 is in fact closed by a close bracket of type 1 as well. This open bracket of type 2 is also closed by a close bracket of type 2. And finally, this open bracket of type 3 is also closed by a close bracket of type 3. This string does satisfy condition number 1. What about condition number 2? As we traverse the string in natural order, this is the first close bracket that we encounter. And the most recent open bracket that we encountered while traversing this string in natural order is this open bracket over here. The two of them are of the same type, and therefore we can conclude that this open bracket is closed in the correct order. The next close bracket that we encounter is this close bracket, and in that journey that we took to reach this closed bracket, the most recently encountered open bracket is this open bracket, and they are both of the same type. So we can conclude that this open bracket is closed in the correct order. And the last and final close bracket that we encounter as we move through the string is this, which is a close bracket of type 1. Now you might say that the most recent open bracket is this open bracket. However, this open bracket has already been closed, and therefore the most recent open bracket that is not closed yet is this open bracket, which is of type 1. So the last and final close bracket that we encountered closes the first open bracket, and we can conclude that this open bracket has also been closed in the correct order. As a result, the string does satisfy condition 2. What about condition 3? We have 3 close brackets, and the first close bracket does have a corresponding open bracket of the same type. The second close bracket also has an open bracket of the same type. And finally, the last close bracket also has an open bracket of the same type. As a result, we can conclude that this example does also satisfy condition 3. Here's another example we can check out. This example has 2 close brackets and 2 open brackets. However, when you traverse this string in natural order and encounter the first close bracket, there is no most recently encountered open bracket. In fact, no open brackets have been encountered at all. Therefore, this string fails to satisfy condition number 2. Alright, now that we have a basic idea of how to check whether the 3 conditions are satisfied or not, let's come up with an algorithm that will do this validity checking for us. If you've been paying attention, you may have got a hint at what the solution might be. Remember, when we checked for condition 2, as we traverse the string in natural order and encounter close brackets, we check whether those close brackets are closing the most recently encountered open bracket. So again, when we encounter a close bracket, it must close the most recent open bracket that we encountered. When you hear most recent, what must come to your mind is last in, first out. And when you hear last in, first out, what should pop in your mind should be stack. So we can make use of a stack to solve this problem efficiently. The open brackets will be pushed into the stack one by one as and when we loop through each character in the string in natural order, and they will be popped every time we encounter a close bracket that closes the most recent open bracket. The top of the stack will store the most recent open bracket that we encountered. Let's go ahead and look at how we can use a stack to solve this problem. So we're going to loop over each character in the string S, and if the character that we encounter is an open bracket, what we will do is we will push it into the stack. So we've now pushed this open bracket into the stack. Then we move to the next bracket which is also an open bracket. When we encounter open brackets, we always push it into the stack. Now we've encountered our first close bracket. And if you remember what we said, when we encounter a close bracket, it must close the most recently encountered open bracket. And we said that we're using a stack because as we traverse the string S and encounter open brackets, we'll be pushing them one by one into the stack. And the result will be that the most recently encountered open bracket will be at the top of the stack. So all we need to do then is to check whether the top of the stack is of the same type as the close bracket that we just encountered. In this scenario, yes, they are both of type 2, so we can conclude that this open bracket has been closed in the correct order. When that happens, we pop the top of the stack and continue traversing. The next bracket that we encounter is also a closed bracket. And when we look at the top of the stack, it has an open bracket of the same type of the closed bracket that we just encountered. They're both of type 3. And therefore, this open bracket has also been closed in the correct order. We pop the top of the stack, and now that we are at the end of our string and we don't have any more brackets to process, we check the size of the stack. Let's look at another example to understand why we check the size of the stack. Take this example for instance. Let's traverse it using our algorithm. Open bracket, so we push it into the stack. Open bracket again, push it into the stack again. Open bracket, push it into the stack. Close bracket, check the top of the stack. The types are equal, so we can pop the stack. Close bracket again, check the top of the stack. Types are equal, pop the stack and move on. Now we are at the end of the string and no more brackets to process. However, our stack still has one open bracket left, and that denotes that the string is not valid because there is an open bracket that has not been closed, which violates condition number 1. All open brackets must be closed and by the same type of brackets. As a result, this string is not valid and we have to return false. And how do we know when to return false in this scenario? We simply check whether the stack is empty or not. If it's not empty, then we return false. What about this example? So here we come across an open bracket and push it into the stack. Next open bracket also will be pushed into the stack. Now we come across a close bracket. We check the top of the stack and it tells us that the most recently encountered open bracket is of type 3, whereas the close bracket that we are looking at right now is of type 2. The types are not matching. This means that this open bracket has not been closed in the correct order, which violates condition number 2, and therefore we immediately return false. We don't have to check the rest of the string. Now that we've talked about the algorithm and the data structure that we're going to use to solve this problem, let's do a little bit of complexity analysis. Let's first start with the time complexity. The algorithm that we're going to use will iterate over each bracket in the string. In the worst case, we have to iterate over all of the brackets. The worst case happens when the string S is valid. Because remember, we said we terminate the loop prematurely if any of the open brackets are not closed in the correct order. Therefore, it's only in the valid case where we'd iterate over each and every bracket. The time complexity of iterating over each bracket is big O of n, linear time. There are, however, some additional operations that we perform. For example, when we encounter an open bracket, we push that open bracket into the stack. And when we encounter a closed bracket, we peek or maybe even pop from the stack. And at the end of the iteration, we check the size of the stack. However, all these aforementioned stack operations can be done in constant time. Therefore, the overall time complexity is still big O of n, linear time. Then what about the space complexity? For this solution, we will be using extra memory. That's for storing the stack. And in the worst case, the stack will need to store as many elements as the size of the entire string. Therefore, the space complexity is big O of n. All right, so now it's time to code out the solution. We start by creating a new function which has a return type of Boolean. The name of the function is valid. It takes in a string s. Now, one cool thing that we can do to make our lives easier is to create a map where the keys are the close brackets of each of the three types of brackets that we're given, and the values are the open brackets. We do this because if you remember, whenever we encounter a closed bracket while looping over the string, we're supposed to know what the corresponding open bracket should be. So we create a map where the key is of type character and the value is also of type character. We can call it close bracket to open bracket. So here we have the three open brackets and their corresponding close brackets. Now we continue with our function. So remember, we said we're going to use a stack to keep track of the open brackets. So let's create a new stack. Then we create a simple for loop that iterates over each character in the string s. At this point, we'll need to check whether the character is an open bracket. So let's create a set that holds all the open brackets. This helps us perform that check in constant time. So if the bracket is an open bracket, then we push it into the stack. And then we move to the next character. So we continue the loop here. So at this point, we know that the character we're looking at is a closed bracket. If that's the case, the first thing we need to do is to check whether the stack is empty. Because if the stack is empty, then we must immediately return false, since there aren't any open brackets at all. However, if the stack is not empty, then what we're supposed to do is to check the top of the stack. And if the top of the stack is an open bracket of the same type of the current close bracket, then we can continue iterating over the rest of the string. So we peek the top of the stack by calling open brackets dot peek, and this will give us the most recently encountered open bracket. And then we check whether that most recently encountered open bracket is equal to the corresponding open bracket of the current close bracket. We get that by using our map. So close bracket to open bracket, because our current character is a close bracket, so we need to get the corresponding open bracket using this map dot get, and we put in the current character, which is the close bracket, to get the corresponding open bracket from the map. If they are both equal, then we need to pop the most recently encountered open bracket from the stack. We do that by calling open brackets dot pop, and then we continue the loop. Here we addressed the case where the top of the stack that holds the most recently encountered open bracket is of the same type when we compare it to the current close bracket that we're looking at. So now here we address the case where the types are not matching. If the types don't match, then we immediately return false. The reason for that is the string has now violated condition 2, where one of the open bracket is not closed in the correct order. Then at the end of the loop, we check whether the stack is empty or not. If the stack is empty, then we can return true, because that means that all open brackets that we encountered have been closed correctly. However, if the stack is not empty, that means there are open brackets that we encountered which have not been closed. So what we do here is return open brackets dot is empty, and that will take care of it for us. There's also a little edge case that we need to address. If you look at the constraints given in the Leetcode problem description, the size of string s can be 1. So at the top here, we can just add if s.length is less than 2, return false. Because for string s to be valid, there has to be at least 2 brackets. And that's it. All right, so let's go ahead and run our code against the test cases. It passes the first few test cases. Let's submit our code, and it's accepted.